Hello everyone, my name is CharlieYu with MemVerge. I run the Director of Systems Engineering here. And in the next 30 minutes, I'm going to give you some high-level overview about MemVerge and the company. The product we developed is called Software-Defined Big Memory Services. And we're very excited about the capabilities of the new big memory that is dawned upon us. And I will also show you a couple of demos of our product, and then you will find that very interesting, very different. All right. So just kind of tell you that our company, our message is memorize the future. We believe the future is a memory-centric future, and then you will see that why that is the case in a moment. A little bit about myself. That's my contact information. So if you have any questions after the conference, you can feel free to reach out. And so yeah, just a quick intro about the company. I know some of you may have attended earlier session with our founder and the CEO, Charles Fan. And so yeah, we are a relatively newer company, started about 3 years ago with 3 key founders, Shuki, Charles, and Yue. And we have a strong heritage from Caltech. So they are from Caltech University. And Shuki was a co-founder for Extreme IO and also Ringfinity. And Charles was the general manager at VMware for vCent. And the Yue was a top researcher in the world for non-volatile memory. And then we're also part of the Intel Capital portfolio company. And then we also have a number of other companies backing us at this stage. I know one of my colleague from Intel, Mark DeMarcy, was going to join us, so I'm not sure if he was able to make that.
Charlie,
Oh, you're on. Okay,
yeah,
great.
I'm on. Yeah.
Okay, great.
Yeah. Hey, thanks. Yeah.
You want to say a few words before we dive into the details?
Yes, thank you. Yes. So as Charlie mentioned, this is Mark DeMarcy. I'm with Intel, and I'm actually the technical sales specialist for persistent memory, PMEM. And I've had the opportunity to work with MemVerge for over a year now, and I've really leveraged their solution to help enable my customers to easily take advantage of the Optane persistent memory technology. And I have to mention that MemVerge just makes it easy. Once you install their product, it's just very simple to understand where to gain value out of Optane persistent memory. And for myself, I do cover the finance industry. So for a lot of my finance customers, they've been able to gain insight to much larger data on their trade market data and making quicker decisions based on that data. So really, I'm glad to have the opportunity to endorse MemVerge, and did also want to let you know that Intel's made a very large investment in MemVerge. So, because there again, as a corporation, we recognize the value that they bring to this technology and to our customers. Thank you, Charlie.
Okay, great. Thank you, Mark, for that. And now let me dive into the technology and then the cover. So one of the things we kind of pioneered in this space is called software-defined memory architecture. So what you see here on the screen, these are the 3 different tiers of the media you can use today in your computer. Right? So you have the DRAM on the top. You also have the SSDs on the bottom. That's where you store all your data. And this new tier here is the PMEM. Is sort of in between DRAM and then storage, and that's the new type of media that Intel introduced in 2019 as a new memory tier for applications. So we really start taking advantage of this new media to bring a new paradigm in memory computing. So if you look at the traditional configuration in our applications, right? You have DRAM, which is very low latency at somewhere around 100 90 to 100 nanoseconds of latency. And then you also have storage where you persist your data onto, and they're relatively higher latency between 100 microseconds to 1 millisecond. And typically you always have a lot of the data being shuttled back and forth between these two tiers via serialization, deserialization. So you can see here we have these 4 data blocks, A, B, C, D. While they're sitting on the storage tier, these are the triangle shape. They're the different type of formatting of the data versus what is in the memory. So there's a very high amount of activity between DRAM and then SSDs. And that's the world we've been living for the longest time. But in the last year, as Intel introduced a new memory tier called PMEM, it basically allowed us, MemVerge, to introduce a new technology into this mix. We call it the software-defined memory. So you can see this shaded area, right? That's our software is essentially managing all the memory, all the data in the memory tier of the DRAM and the PMEM tier. And we place the data intelligently across these two tiers to maximize the application performance and also the efficiency of the data placement. So as a result of this, all the data here, all these blocks, they're all native memory format, right? So that's your data structure, that's your array, that's all your declarations all here. So there's no serialization or deserialization process, all happen in the memory. Okay, so that's the first thing. And as you can imagine, this brings out a lot more performance for your application, since you no longer have to travel all the way down to the storage tier, right? And also, now we have our data resident in the memory. I can do, we can do a lot of more interesting things. We can snapshot the data to keep it persistent in this media, so we can record that snapshot within a couple of seconds to restart any in-memory application. We can move around, we can send that to the public cloud, we can do a lot of things with it. So the possibility is just endless with this new memory tier that brings us to our applications. So yeah, this is a sort of a picture of what PMM looks like. So this Optane PMM, it feels just like a regular DDR form DRAM, right? It's the same form factor. The main difference is it has much higher capacity with slightly higher latency as well. So you can see here the MemVerge big memory, memory machine software is really here to manage all the memory in the system so that the application doesn't have to be redesigned and modified to use this new media. And today we support many applications from in-memory database applications to traditional applications to machine learning and AI applications. Just all gamut of application is being supported. And then we do that through something called transparent memory servers, right? Because all these applications today, they don't have knowledge of DRAM versus the PMEM. All it knows that it has some needs to allocate X amount of memory on the system. So transparent memory services allow us to be backward compatible with any memory allocation calls from these applications. And at the core of our software, essentially is managing both PMEM and the DRAM, and also be able to intelligently place the data on the DRAM and the PMEM when the data comes in. Okay, so that's the first thing. The second is be able to snapshot that data onto the memory, right? Because in order for us to persist that data without rewriting, the way we do that is really snapshot it. So you can always record that back later. And I'll show you what that looks like in our product. And then the last piece is around network replication. So today, you can replicate these memory snapshots between systems. You can replicate between systems on-prem, or you can replicate from on-prem to the public cloud, or back and forth, right? Or vice versa. And the reason you want to do that is Basically, this allows you to essentially do things like cloud bursting, cloud migration for your application. Since everything is already encapsulated in the snapshot, it is just so much easier to move them around easily with our software layer. Okay. So one of the things that really stand out in using memory machine is the performance. So as you can see here, if you run an application, in this case would be an example of MySQL, right? To run MySQL completely in DRAM, it is going to be very fast, right? But if you use PMEM to run the same application, it will be a little bit slower. But with our software, you have the option to mix in DRAM with PMEM, okay? And the ratio between DRAM and the PMEM is really, any to any, so you can put in as much or as little as you want. And you can see the benefit of that is the more DRAM you mix into the PMEM, the better performance it gets, to a point that it could potentially be faster than the DRAM performance, okay? And then that's what you can get from our software. The other feature in the software stack is really around autosave and a fast restart. A lot of the in-memory applications, when you restart these applications, it takes quite a while to rehydrate the data from storage to memory. And not only that, once the data is there, the data may be cold, and then it takes maybe another a few hours or 24 hours to warm the data back up to a state that it's fully functional. So wouldn't that be nice if I can just restart my in-memory database or in-memory application at a warm state, right? Leverage some kind of in-memory capabilities. And that's what this feature is all about. So it looks something like this at a high level. So you allocate some memory on the system, and every so often, right? So you can have the MemVerge software to do something called a autosave. Very much like how you work on a PowerPoint presentation, and then Microsoft PowerPoint is saving that document for you in the background every few minutes. So in the event if you crash your laptop or computer, your work is always there. You can go back and then restart. You don't have to worry about losing the data. The same idea here is our software is going to save the work of your in-memory application, and then we save that in the memory, right? So you allocate, we save, you allocate, we save. And let's say something happened, right? There's a crash of the application or something went down. You can always recover to the last snapshot. And this recover process is instant because the data is already in memory, and it's just a pointer operation to move to point to where the data was at that point. So we call that zero IO snapshot, right? There's no storage IO involved. And for that reason, it's very fast. So we have an example here. If you're thinking about like a typical in-memory database, such as Redis, with let's say a couple 100 million keys, in this case 300 million keys, we can restart that in like half a second, right? So it'll be 1500 times faster than just restart from the beginning from storage. And a lot of the customers find that very, very valuable for their mission critical environments. So now we have the snapshot in the memory. The other thing we could do is what we call a thin clone, right? So what does that mean? Just imagine you have an application and then you have already snapshotted. Once you have a snapshot, you can always roll that application back to the point of the snapshot, which is fine. But the other thing now you can do is to take that snapshot and then turn it to a new application, right? A clone of the original application. So why do you want to do that? Well, in some cases, you may have a need to upgrade this application to a newer version. So wouldn't it be nice if you can do a test run of this upgrade by snapshotting this application and perform the upgrade on the clone before you perform the actual upgrade on the real application, right? So if something goes wrong, and then you know how to fix it, and that's the benefit of the cloning. Or in some cases, you may have multiple clones to hand off the same application to a few other groups, other teams, have them have access to the same application without having to log in or directly access the application that you're running. So cloning is a great feature, and it uses no extra memory. That's why we call it thin clone. So you can think about thin clone is some kind of some type of memory deduplication. Right? So it's very cool, and you can do a lot of things with it. So that's the 3 features that we discussed today. We have a lot more capabilities that we're building in our software that we're very excited about. But for today, I'm going to give you a very brief demo of our product, and I will do that primarily through the slides. So we'll show you what it looks like. So with our software, you also have a dashboard. The dashboard gives you essentially an overview of how much memory you have and how much you're using and how they're performing, right? So every time you deploy MemVerge software in the environment, you can also deploy the GUI, and you can add multiple hosts in this GUI to manage many systems. Okay, so that's the dashboard. The other view in the software is at the host view. So you can looking at each host to understand what's the operating system, how much memory is using, and also memory level metrics, right? You can have DRAM metrics and also PMAM metrics. So let's drill down into these metrics. Within DRAM and the PMAM, we allow you to look at something very interesting. So if you're running some application in memory, we can show you what is the performance in real time. And not only that, we can give you the breakdown across multiple NUMA, like multiple sockets on that system. And you can graph out, how much memory and what's the performance bandwidth of the memory you are using. And it also trends the usage for the last day, last week, or even the last year, right? So a lot of very useful memory level stats. It's at your fingertip with this GUI. And so then you may wonder how difficult it is to use MemVerge software. Like, what does it take for me to run it? It's really simple. What you see on the screen is I'm running KDB, right? That's one of the in-memory database. And as you may know, you launch KDB by running the letter Q, and then you can append a query next to the command. So in this case, is insert-nps.q. So you run this, and it will give you a number of results, right? How many millions of inserts you made to the database, right? That's the command, and that's the result. So to do the same thing, running using MemVerge, all you gotta do is start with the 2 letters MM, and the rest is exactly the same, right? So there's no modification in your database, there's no modification in your software, and there's no plugins, there's no kernel level plugins. Our software runs entirely in the user space, and so it's very friendly to any of the stock kernel operating systems you run. Okay, and that's all you had to do to run it. And in this case, you can see we are able to outperform the system with DRAM with our memory allocation memory allocator. Okay, and once you're in the GUI, you also have the ability to snapshot your application running in memory. In this case, I'm using a different example here. That's Redis. So Redis is currently running This instance of Redis is using 173 gigs of memory. That happens to be all landing on PMEM on the persistent memory. They also have a small amount of memory sitting on the DRAM. That's why you can see here it's volatile, 15.73 megabytes. So what I can do is I can take a snapshot of this memory, of this Redis instance in the memory. And the very first snapshot I take is telling me that it's using 173 gigs of memory. It's using about 12.23 megabytes of the metadata that is tracking the memory pages. Okay, and for every subsequent snapshot I take, you can see here that's how much more Redis is growing over time. And I'm taking these snapshots, and these are how much snapshot space is taking for the metadata. And so now I have 1, 2, 3, 4. I have 4 snapshots. With these 4 snapshots, I can restore to these previous points. So if I come over here, I say I want to stop this Redis, or I can just go to the application, do a shutdown. Once I shut it down, I can come over to the GUI and then say restore, and within 1 to 2 seconds, my Redis is back up running. Okay, so that's how easy it is to using the software and instantly restart any applications. Okay, so now with these snapshots, the last thing you can do is clone them into a new instance. Okay, so in this example here, again, I have Redis running. This is the PID of Redis, and this is a smaller database. It's about 26 gigs of the memory it's using. And essentially what I did here is I just cloned this database on the same server, and this is a new instance that just launched from the clone. And you can see here it's using no memory, right? When the clone is created. Okay, so over here I can do some testing. I can do a test upgrade of my Redis and so on and so forth. Okay, so what systems do we support today with MemVerge software? So we do support both DRAM only, as well as system with both DRAM and the PMEM. So if you do not have PMEM in your environment, so you can try out our software with your current hardware using our software. If you have PMEM, it's supported on Intel Cascade Lake or beyond, right? So that's supported for that. Operating systems, so we support CentOS and the RHEL 7.6 or higher, and any system with at least 128 gigs of memory will run perfectly fine. Our software runs as a background process on the Linux server, so it's very, very lightweight. It uses just megabytes of memory on the system. And in terms of the environment we support, we obviously support bare metal server. We also support virtual machines. So if you're running VM in vCenter 6.7 or higher, that's all supported. KVM is supported, as well as Red Hat OpenShift containers. You can also run our software in the public cloud. So today you can download our software, run that in AWS and Azure. Okay, so that's a quick overview about MemVerge, and really thank everyone to watch this webinar. Yeah, let me know if you have any questions. I think we have about maybe 5 minutes.
Thanks, Charlie. Yes, if you have any questions, please put them in the questions panel in the GoToWebinar Control Center. We had one question, but I think you just answered it on the last slide about running this on DRAM only servers and running it in AWS.
Yep. Yeah, we do allow customers to do that. Yep. Yeah.
All right. It looks like that's our questions for today. Thanks, everyone.